In this example, we're going to assume that we want to solve an equation by factoring, and the equation that we're working with currently looks like 3x times 2x plus 3 equals 10 minus 2x. If I want to solve this by factoring, my first step is going to be to get it in standard form and equal to 0. So I would distribute the 3x times the 2x would give me 6x squared. And then the 3x times the 3 would be plus 9x. And this is equal to 10 minus 2x. So distribute. And then we're going to continue on this. We're going to want to, oops, I didn't change the color on that one. We're going to want to move the 10 and the 2x to the other side of the equation. So I'm going to add the 2x and I'm going to subtract the 10 to get those to the other side of the equation. So the 6x squared is not going to have anything like terms with it, so it'll stay the same. The 9x, if I add a 2x to both of those sides, the 9x plus the 2x will give me 11x. And then if I subtract the 10 from both sides, it's going to be a negative 10. And then it'll be equal to 0. So it's moving those two terms over. Okay, so if your equation is not yet equal to 0, the first thing that you'll want to do is get it set equal to 0. Now, we're going to use the AC method or the sum product method. Sometimes it's called either one of those two things. So we're going to be looking for the two numbers whose sum is our middle value. So the sum needs to be 11x. So my sum is going to be 11. And those same two numbers need to have a product that is the product of the first and last terms, the A term and the C term. That's why this is also sometimes called the AC method, because I'm looking for the AC product here. So the AC product, 6 times negative 10, is negative 60. So I'm going to be trying to find two values who have a product of negative 60 and a sum of 11. All right, so I'll start with trying to determine what goes into negative 60. And actually, because I know that my 60 is negative, I do have some additional information. I know that because 60 is negative, I need one positive and one negative number. Also, because the 11 is a positive number, if I'm adding up a negative and a positive number and I'm adding to a positive, I know that out of these two, the positive number has to be the larger number. So I know a lot about what these two numbers should look like. Okay, so thinking about numbers that go into negative 60, let's see, 6 and 10. If I did 10 minus 6, that would give me 4. That's not 11, so that doesn't work. We'll try again. Let's see, 60. If I divide 60 by 3, that's 20. So 20 minus 3 would give me 17. That also doesn't work. What about 4? 4 goes into 60 15 times. So 15 minus 4 is 11. Now that one does work because I did want to get the sum of the two numbers, 15 plus negative 4. That is a sum, even though I'm adding a negative on, it looks like subtraction. I'm still taking 15 plus negative 4. I get 11, and that works. That means that these two numbers are our correct pairing. Okay, so we are going to rewrite our original set equal to 0, and we are going to split up this 11x into the sum of 15x minus 4x. Okay, so when I write this down, I'm going to have the 6x squared plus the 15x minus the 4x minus the 10 equals 0. So we've taken that sum piece and we have split it so that The 11 is composed of those two separate pieces. So instead of the 3 terms that we originally had, now there are 4 because we've broken up that 11 into the 15 minus 4x. Okay, so from there, our next step is going to be using the grouping method on the first 2 terms and on the last 2 terms. So if I group the first 2 terms, I'm going to factor what is the GCF, the greatest common factor, out of each of those 2 pieces. So in the 6x squared and the 15x, I know that I can divide both 6 and 15 by 3, and also these terms both have an x, so we'll be pulling out 3x. When I divide 3x out of the 6x squared, 2 and an x will be left, and when I divide 3x out of 15, the 5 will be left. I've taken the x out, so there are no x's left. Okay. On to the next pairing, we're going to group the negative 4x and the negative 10. In this pairing, because the negative 4, the first term is negative, we're always going to pull a negative with our GCF. So it's going to be a negative 2 that I pull out because 2 goes into both 4 and 10. They don't both have an x, so I can't take an x. I can just take the negative 2. Then, when I divide negative 2 out, negative 4 divided by negative 2 is 2. I keep the x. And then negative 10 divided by negative 2 is positive 5. And we have finished up on that piece. It's still equal to 0. All right. When we get to this stage, we'll know that we are on the right track or factoring correctly if our binomials are the same. So the 2x plus 5 that I got from the first grouping is the same in the second grouping, another 2x plus 5. That 2x plus 5 will come out. It is in common between these 2 groupings, and the other parentheses is going to be filled in with what I took out. So it's going to be my 3x from the first minus my 2 from the second, and it's set equal to 0. Now this is completely factored for this question. Once factored, if my goal is to solve, so this was an equation, it's equal to 0. Once factored, I will set each of my factors equal to 0. So for example, 2x plus 5, the first factor, is equal to 0, and the 3x minus 2, the second factor, is equal to 0. We'll solve each of those factors. We can drop the parentheses at this stage. We'll solve each of those factors by rearranging the equation to get x by itself. In the case of the 2x plus 5 equals 0, we'll subtract 5 from both sides, so 2x would be equal to negative 5. And then if you divide both sides by 2, you'll get x equals negative 5 over 2. Or you would just leave that in fraction form. It was supposed to be an x, by the way. There we go. In the next one, if I were to add 2 to both sides, that would give us 3x equals positive 2. And then I would divide both sides by 3, and I would get x equals 2 divided by 3. So I would have those 2 solutions there, x equals negative 5 halves, and x equals 2/3.